Good evening, everybody. In the last class, we have discussed the sinusoidal pulse width modulation techniques, both unipolar and bipolar also. And I received a few questions, few doubts from your class. So the doubts are first thing is how you have chosen this one, alpha 1, alpha 2, alpha 3. Right. See, this is I have generated from the MATLAB simulation with modulation frequency. I mean, MF ratio is equal to 7. For that, from the simulation, I calculated this alpha 1 and alpha 2, alpha 3 values. So for that, so we got these results. Okay, this is randomly I have taken only. So this based on the simulation, MF is equal to 7. So I have taken this alpha 1 is equal to this value, alpha 2 equal to this one, and alpha 3 is equal to 77.5. So that is randomly I have taken for one cycle for MF is equal to 7. So whether MF is equal to 7 or correct or not, you can see here. See, this is your 7, H7. This is MF is equal to 7. For that only you are getting higher harmonica. So I already told you how you are getting this sideband frequency. This is MF frequency, carrier frequency. This is sideband frequency. So this is one question. And the second one is later I have taken this waveform. So this is MF is equal to 15. For that, if you observe the simulation, 15. For that you are getting this 50. At 15 only you are getting exactly. Okay. So here what is the conclusion is, if MF ratio is increases, see the third harmonic, fifth, seventh, ninth, and are going to be reduces. So if a number of carrier waves are increases, right, carrier frequencies increases, then lower order harmonics are going to be reduces. All these lower order harmonics. That is the main advantage of sinusoidal PWM technique compared to multiple pulse width modulation as well as a single pulse width modulation. So that's why we are using generally this sine PWM. This is also one question was asked, why in what way how sine PWM is better than that of multiple pulse width and single pulse width modulation. So that's why I'm using, because of this reason I'm using. In case of single pulse width modulation, for example, if you want to eliminate third harmonic, remaining harmonics are present. In case of multiple pulse width modulation, all harmonics are present but magnitudes are reduced based upon your pulse width. So these two things, and here compared to those two pulse width modulation, lower order harmonics are reduces. So if you increase the carrier frequency, MF ratio is also increases, then you will get the carrier frequency somewhere else, wherever you have chosen that carrier MF ratio. Let us say, for example, MF ratio is 50, then you can get there only, right? At the particular 50th frequency, you will get the harder harmonic increases. But if you get 50 means what happens is the filter size is reduces, so THD is also going to be reduces. So that is the thing I want to say. These two doubts in the last class, some of the students are asked. So that is the thing. And coming to this, sometimes, so these values sometimes in the examination they will give. In the 2014 GATE examination, they have given this. Some of the values they have given. You have to find out one value. Otherwise, they will give the fundamental component. You have to find out the alpha value. Like that, they will give. So, but this from last class I told you that this Bn equation is valid only to represent fundamental component only. When you want to go for another, I mean to find out this B5, B6, HF13, HF15 or B15, whatever it may be, then you have to go for this double Fourier series concept. Then only it is possible to calculate the required harmonic values. Let us say 15, B15, B like this. So this is the example also I have shown. Okay. So you please follow these examples, then you will get the exact answers for that. Okay. So that is about the last class. And now we will go for the series inverter. So in the series inverter, so why you are calling it a series inverter is, so the load, R load is connected in series with your L and C. Here L and C components are acting as commutating elements, right? And for example, if you forget about this one, just imagine that you just forget about this one. This will be exactly class A commutation, which is called as load commutation. So before you are studying this concept, if you go to the class A computation, it is better to understand. It is easy to understand this concept, right? So here, this is your I naught curve, and it's a voltage across capacitor, and it's a voltage across inductor, right? Now see here, this is the R load. For this R load, right, the current is flowing like this, means based upon your current shape, your voltage will be developed. So here already the output current shape is sinusoidal, so your output voltage shape is also going to be sinusoidal. Understand what I am saying? So for this, to get the sinusoidal output voltage, therefore what is the advantage? You will get the what happens, the harmonic content are going to be very less because of pure sinusoidal, right? So if you reduce this t of time, then pure sinusoidal waveform you will get it. Okay, so that we will discuss later, right? So one by one we will discuss one side, right? Here initially we have to assume some values. See this one. This voltage, initial voltage across capacitor is minus Vc. Initial voltage across inductor is VDC or Vs, whatever remember, source voltage. Okay, you can take this one. And initial current is 0. Right. So these are the reference polarities, plus minus of inductor, and this is the plus minus of capacitor. Okay. This is the reference current direction. This is the reference current. Whenever the current is entering into the load, that is called a positive current direction. You can assume it. Okay. So now we'll go for the first mode of operation. Right. Mode 1 from 0 to T1. Right. What I have done, they have given the gate pulse to thyristor T1, and immediately it will turn down. Turn down. Why? Because positive is applied to anode, negative is applied to cathode. You want to can see the previous slide. See, this is anode and this is cathode. Therefore, positive is applied to anode, negative is applied to cathode. So that's why it is forward bias and it is turned on. So once it is turned on, what happens? The current starts flowing through your load, right? Along with L and C components. L and C components is nothing but commutating elements. Because of these two elements only, your SCR will goes to turned on. Okay, right? So see here, initial values I have written and final values I also have written. Okay. So what is the initial value of the capacitor? Minus Vc. And what is the initial value of inductor is Vs. That I have used. So once it is turned on, slowly the current will be flowing like this, right? So once the current will be flowing like this, what happens? Because of L and C, so you will get slowly the current will be increases, right? L and C, because slowly current will be increases, because inductor does not allow sudden changes in current, so that's why slowly the current will be increases like this, right? Similarly, your capacitor voltage, initially what is the capacitor voltage? Negative voltage. Now because of current is flowing in this direction, right, the capacitor slowly the capacitor reaches to with minus Vc to 0, as well as again it reaches to VDC. See, this line is nothing but VDC or source voltage, right? So now what is our conclusion here is, in this mode of operation, your capacitor will charges from negative voltage to positive voltage up to VDC here, right? See, this is minus Vc and this is 0, and later what happens? It is charged to a voltage of VDC, right? At the instant, what is the inductor is? Inductor voltage is 0. Here what happens? See, always you know that the current and voltage angle difference between these two are 90 degrees. See, here it is 0. See, here it is 0, right? So here it is maximum. So once it is maximum, what happens? Definitely the voltage should reaches to 0, right? So 90 degrees phase shift. Understand what I am saying? So that's why your inductor voltage reaches to 0, right? So see, these are the initial values and final values here. Capacitor mode 1, what is the final values? VDC. This is the mode 1. Final value is it is charged to voltage of VDC. And inductor it reaches to value of voltage of 0 volts. These are the final values. Now here what is very important point you have to identify is the capacitor voltage, right? The capacitor voltage is charged to what is the value? VDC. This is also VDC. Both voltages are same. So whenever both voltages are same, actually the current should reaches to 0 for as per our circuits concept, right? But right? At the instant of t1, what is the current here? Maximum value. The current cannot reach zero here, though your voltages are same, because inductor does not allow sudden changes in current. Due to this reason, right, what happens? Still you have maximum current. So even though the both voltages are same, right, because of current is maximum, your SCR T1 will not turn off. To turn off your SCR, two conditions must be satisfied. One is the current reaches to zero, another one is reverse voltage, right? So but here at the instant of t1, exactly the both voltages are same. It's not a reverse voltage, still it is not appear. And what about the current here? Maximum. So both conditions not satisfied here. So that's why still your device is in on state. Now from t1 to t2, what happens? See, because from t1 to t2, from T1 to T2, still because of your SCR is on, again the current will be flowing like this only, and the capacitor will reaches to a voltage of VDC plus VC. The capacitor voltage will reaches to a voltage of VDC plus VC. And here what happens? Because of highest potential, see here, compared to this potential VDC, I'm sorry, here VDC should present, compared to this potential is less. So that's why slowly the current will reaches to zero, right? So once this current reaches to zero, what happens here? It reaches the maximum voltage. What is that one? VDC plus VC. And coming to at this point, what happens? Your inductor voltage is zero. Why inductor voltage is zero? You know that formula of inductor voltage, VL is equal to L into di by dt. Here di by dt is zero. Therefore, once it is zero, your inductor voltage is also zero. So in the previous mode of operation at T1, the voltage across inductor is zero. Now at the end of T2 also the voltage is zero. Coming to capacitor voltage, in the previous case, what is the voltage across at the instant of T1? What is the voltage? VDC. See here, initial value is VDC. So this is VDC. It's not VC. Just assume it is a VDC. Okay, VDC. And at the end of this mode, what happens? This is VDC plus VC. See here, this is VDC plus VC. Right. So because of highest potential, this potential is greater than this VDC potential, your current is zero, right? Slowly the current reaches to zero, right? So please assume this is VDC, it's not VC, it's a VDC. Okay. Next, coming to now two conditions are satisfied. What are the two conditions are satisfied? See, the first condition, the current reaches to zero. See, whatever the current you are getting from SCR, the same current will flows through the load. So that current reaches to zero. And second one, reverse voltage. See, now this voltage is greater than that of your source voltage. Now this voltage is greater than source voltage. Therefore, reverse voltage also appeared. Therefore, your SCR will goes to on. Understand what I am saying? See, that's why I have written here T off. Right. In this period, no operation will be presented. Right. Now we'll see that. Right. Now see, in this mode of operation, because of two conditions are satisfied here, right, your SCR is turned off. Once it is turned off, what happens here? Your capacitor voltage will remain same, right? And already the inductor voltage is just to zero because of your di by dt is zero. Therefore, your output voltage, I mean inductor voltage across inductor is zero. That's why I have represented. And the voltage across the load is also zero, because here what is the current? Zero. Once the current is zero, the load voltage is also zero. So this is about your mode 2 operation. Understand what I am saying? Right. Now look at here again, one more point. Here now see, this voltage is greater than this voltage. So never, even if you give the gate pulse, it won't be turned off. Turned on, sorry, it won't be turned on. Right. Now what is the voltage across this capacitor means? If you apply the KVL through this part, this VDC and VDC gets cancelled. Therefore, what is the voltage is minus VDC will appear. And once here the voltage is zero, here the voltage is zero. What is the voltage here? It will be there. So it will be there across this VC, whatever you are having here, VC, VDC plus VC, the same will be appeared across this VT2. Okay. So here VC is nothing but just I want to say that it's a capacitor voltage. Here what is VT2? VT2 is nothing but, so the total voltage VDC plus VC will be appeared across this VT2. Of course, that is not that much important, right? So here VT2 is nothing but what happens? VDC plus VC. Okay. So here you just change, this is VDC plus VC. Understand what I'm saying? So this is our third mode of, T2 to T3. Okay. Next mode of operation from T3 to T4. Now, if you see, this is T2, this is actually anode, this is actually cathode. Now see, this positive polarity is favored to anode, negative polarity is favored to cathode. That's why it is a forward bias, right? So now, if you observe, at this instant of T3, I will give the gate pulse to your T2. So this is the gate pulse I have given at this moment to the thyristor T2, and immediately it will turn on. Once it is turned on, what happens here? Here what happens? Earlier initial value is VDC plus VC. Slowly the current will be flowing in this direction. Understand? Slowly the current will be flowing in this direction because this is off state. Definitely the current will be in this direction. Now see, the current is flowing opposite to that of your reference one. Earlier, see, if you want, I will show. So earlier the current is flowing in this direction, right? So in this direction. Now what happens? The current is flowing in the opposite direction. So that's why the current will be negative. Your developed voltage is also going to be negative. Okay, see this. These are the reference polarity. Now this is the applied polarity. What you are getting now, right? Because of this current, right? So once the capacitor is discharging like this, so at the instant of this point, what happens is the voltage across capacitor will reaches to VDC. So this is initial value and this is the final value. Next, coming to the inductor. So at the instant of T3, what is the voltage? It is 0 only. Again, at the instant of this point, exactly T4, again the voltage is 0. So that's why I have written again the voltage is 0. Voltage across inductor is 0. Understand? This is about in this mode of operation T3 to T4. Okay. Next, here at the instant here, what happens? Still you are having maximum amount of current, so your T2 will not be turned off. So still it is in on state only because the current never becomes to 0 immediately. Next, see here from T4 to T5, as I said, your T2 still it is in on state. Therefore, still the current will be flowing like this. Understand what I am saying, right? So at the time of starting of T4, what is the value of voltage across capacitors? VDC. Now, because of your device is in conduction, the current will be flowing like this, and the capacitor voltage will reaches to reverse polarity VC, reverse polarity VC, right? You can say this capacitor will reaches with a reverse polarity because of the current is flowing in this direction. The capacitor will charges to a reverse voltage. Earlier, what is the polarity? Plus, minus. Now, because of the current is flowing in this direction, what is the voltage polarity is opposite, right? So now it is charged to a voltage of VC, right? So here I have written VDC, just take it as VC only. Okay, this just considered as VC. Okay, so and again, see, once it reaches to a mode, this whatever we are written here, the same mode it will be appeared here. Again, you will start the next mode of operation. Understand what I am saying? So again, here at this instant, what happens? Again, we have reached the initial polarity, right? At the end of this mode, coming to the voltage across inductor. See, at T4, what is the voltage across inductor? 0. Now, once the capacitor reaches to maximum value, so again the inductor voltage is 0. Again the voltage inductor is 0. Why inductor voltage is 0? Here see, the current will becomes to 0. Once the current will becomes to 0, the di by dt is 0. Therefore, voltage across inductor VL is equal to L into di by dt. That is nothing but 0 because this current is 0 here. This current is 0 here. Therefore, obviously your inductor voltage is also 0. Here only the change is small change. Here instead of VDC, just write on VC. That's it. Okay. So just small correction. So this is about from T4 to T5. At the instant of T4, what is the current here? Maximum. So that's why your SCR does not turn on. Right. So at the end of this mode, what happens? This capacitor magnitude is this one. So now VC, this is VC, small voltage VC. So again for the next case, this positive is up here to anode, negative is up here to cathode. Understand what I am saying? Then for the next cycle, it will be forward bias. So this is the case for the series inverter, right? So here just assume it is a VC only, it's not VDC. So this VC is less than that of your VDC. That's why your ACR will be turned on for the next cycle, right? I am showing only up to T4 to T5. For the next cycle, when you want to repeat this case, then what happens here? Only VC is there. This VC is this whatever VC is less than that of your VDC, right? So that's why your T1 will be on. Again, the same cycle will be repeated. Understand what I'm saying? This is your series inverter. Generally, it will be used in induction heating. The main advantage is because of the load, you are getting a sinusoidal waveform. For example, if T off is very less, then what happens? You will obtain almost a sinusoidal voltage wave. That is the advantage. But what happens here? To turn off this by using load, it will be turned off. But here, what happens to turn off this one? What happens here is again. So if you observe, see at this instant the current is zero. At this instant of point, current is zero. So first condition is satisfied. And second one, what is the voltage? Negative voltage. See this negative voltage. Negative is applied to anode, positive is applied to cathode. So this is also satisfied by using load commutation only. Your T1 and T2 will be turned off. No forced commutation is correct. Understand what I'm saying? For to turn off this T1 by using this load, it will be turned off. For T2, see here the current reaches to zero and a negative voltage. See this negative is applied to anode, positive is applied to cathode. So two conditions are satisfied. Therefore, your T2 will be turned off when you give the signal to this thyristor T1. Understand what I'm saying? So this is about your series inverter. It's a very simple concept, but carefully how to understand the polarities as well as the current direction and all this. Okay, right. So next one is parallel inverter. So why it is called as parallel inverter means your this capacitor is connected to your load parallelly. So that's why it is called as parallel inverter. Here this inductor and this capacitor will act as a commutating elements. Of course here the inductor role is only to make a constant current. That's it. But main commutating element is this capacitor only, which is connected parallel with this one. Here we are using one isolation transformer also. That transformer is 2:1 rating, right? So here this E will store Vs as well as this will store Vs. Understand? Right? So this is about this one, and this is the VT1 reference, right? So this is your VT2 reference. This is I0 current, load current. So this is I0 is nothing but a constant current. Here this capital I0 is nothing but constant. Here this is the polarities of your reference polarities of your capacitor. Now we'll discuss the first mode of operation. So in the first mode of operation, before we are entering, so assume that initially the capacitor is charged to a voltage of 2 Vs. Understand what I am saying? And initially you just assume the voltage across the load is constant. Load is Vs. So these 2 points are important, right? So this is the mode 1 operation from 0 to T1. From 0 to T1, which thyristor will be on? T1 will be on state. In T1 will be on state. Once T1 is in on state, see how the current will flow. The current will flow plus Vs, inductor, this transformer primary winding, upper winding, and this midpoint onto the load. Right. Then how you are getting your charge to this capacitor to 2 Vs. See, actually I said that this is 2:1 transformer. The current is flowing only with this winding. So then what I want to say is here transformer is nothing but what happens, your mutual flux linkage is there. So whenever the current is flowing like this, you are having some voltage Vs. That voltage will be linked to that flux, magnetic flux will be linked to the lower winding also. So once this flux is linked to this lower winding, then what happens here? It will generate Vs voltage. Here also it will generate Vs voltage. So that what is the total voltage? It is charged to voltage of 2 Vs. Understand what I'm saying? It is charged to a voltage of 2 Vs. Okay, right. So now look at this carefully. Understand my point. So this positive now appear to cathode. This negative appeared at anode. See, obviously here cathode you have positive means anode you are definitely having negative. So now what is this magnitude? 2 Vs. What is this magnitude? Vs. Now what happens? This voltage, this voltage will be greater than that of your this source voltage. Therefore, the thyristor will be ready to turn off, but your SCR won't be turned off in this period, right? But when it will be turned off, once you will give the triggering pulse to thyristor T2. So meanwhile, even you have 2 Vs, it won't be turned off, right? So once you will give the triggering pulse to thyristor T2, right? So what happens? A reverse current will flow through thyristor T1. So once the thyristor is having reverse current, what happens? The charge carriers, all the charge carriers present in the thyristor will be removed and it will be completely turned off. Understand what I'm saying? Right. So see, look at here. From 0 to T1, even you have voltage across capacities 2 Vs magnitude, your T1 will not be in off state. Still it is in on state. Please understand carefully. Why it is an on state means still your SCR T2 is in off state. If you give the triggering pulse to this thyristor T2, then a reverse current will flow to thyristor T1 and it will be turned off. So that is in dynamic characteristic we have already seen in class D and class C also. I have already shown class C computation and class D computation. Just once you please refer that. Okay. So now at this instant T1, now what happens? I will give the triggering pulse to thyristor T2 because this negative is applied to cathode, positive is applied to anode. So these polarities are favored to your thyristor T2. Then I will give the triggering pulse to thyristor T2 here, right? So now we'll see from T1 to T2. So from T1 to T2, what happens? See, I have given the triggering pulse like this. So once immediately what happens? A sharp rise of current will flows like this in this fashion, reverse current. Then immediately T1 will be turned off, right? Then what is the other way of current flowing? This way. So the capacitor voltage polarity, these are the reference polarities, right? Initial polarities. Now the current will be flowing in this fashion, right? The current will be flowing in this direction, right? So at the end of this mode, what happens? Because of the current is in this direction, it will charge to a voltage of minus 2 Vs. Okay, right? And one more current will be flowing through this. The current flowing through this T2 is how the current flows. It's plus Vs, inductor, thyristor T2, and to the lower winding of the transformer, and return to the minus. Understand what I'm saying, right? So now here, now if you observe the IT1 from T1 to T2, T1 is in off state. Therefore, what happens? The current flowing through this 0. From T1 to T2, right? From T1 to T2, right? T2 is in conduction. T2 is in conduction. So that's why a constant current will be flowing. See, this capital I naught is nothing but it's a constant current because of a pure inductor, right? So that's why you are getting a constant current. Understand? Right. Now, see, the capacitor voltage, carefully understand, initial polarity is plus minus 2 Vs. Now, because of the current is flowing in this direction, it will charge it to a voltage of minus 2 Vs. So, VC is charged from plus Vs to minus Vs. Next, coming to output voltage. See, because of the current direction is in the reverse direction, right? So, current direction is in reverse direction. So, and the polarity, whatever the polarity here at the end of this mode, what are the polarity? These two polarities. So because of this polarity is changed, your output voltage polarities are also changed. See, initial polarity, this is plus and minus. Therefore, here also this is plus and minus. Now, because of the current direction is reversed, the output voltage, the voltage across capacity is changed. Minus 2 Vs. This is minus plus, opposite to this one. The same voltage polarities are existed here, right? So that's why you are having the voltage will also goes to negative. Right. Next, coming to VT1. What is VT1? See here, at the instant of this point, right? So still your capacitor having positive voltage because the capacitor does not allow sudden changes in voltage. So that's why in this period still it is having positive voltage. So that's why in this period, so this positive is applied to cathode, negative is applied to anode. So that's why you are having negative voltage. Now here what happens? It is negative voltage. That means this voltage. Now what happens? Negative is applied to cathode, positive is applied to anode. So that's why you are having positive voltage. Once it reaches to capacitor reaches to full voltage of 2 Vs, here also you will get 2s. Here voltage across capacitor, voltage across T1 is also 2s. Here mostly these two are important. Look at here again, I'm repeating. So at the initial polarities are these two, plus minus, right? So because of this one, positive is applied to cathode, negative is applied to anode. So reverse polarity. So that's why you are having reverse voltage. Next here negative, when you are having negative voltage, that means these polarities are coming into the picture. Negative is applied to cathode, positive is applied to anode. So these polarities are same as that of your reference polarities. So that's why you are getting like this. Once it reaches to constant voltage, your capacitor voltage across SC are also same one. Okay. So whatever this magnitude, you will get like. Next IC. What is IC? See here. Actually, in the previous slide, so this is the actual capacitor current direction. This is the actual capacitor current direction. Now, if you see how the capacitor current direction reverse, right? It is in reverse. So that's why you are having the reverse one. Suddenly it rises. Why? The capacitor will allow sudden changes in current, right? But slowly it decreases, right? So because of inductance is also there, slowly it is decreases like. Okay. If you apply the current equation for L and C, and you will get this one, right? Or otherwise, you please refer my classic commutation notes. The same concept you will get. Okay, right. So this is about this in this mode of operation. So now see here, the capacitor current reaches 0 here, right? But still your T2 is in conducting in this period. Why the capacitor current reaches to 0 at this moment? See, now at this point, your capacitor reaches to a full voltage, 2 Vs, full voltage, 2 Vs it is reached. So once it reaches to full voltage, the capacitor acts as an open circuit. Once the capacitor acts as open circuit, the current reaches to 0. But why this T2 is in conduction means there is no relation between this capacitor current and this T2 current. So the current, the T2 current, how the current will flowing? Plus Vs, inductor, this T2, and through the lower winding of transformer, and through like this. Understand? So here this current direction, there is no relation. So that's why still your T2 is in conduction. But at this moment, the capacitor reached to a full voltage, right? So that's why what happens, your current reaches to 0, because once it reaches to capacitor reaches to maximum voltage charging capacity, it acts as a open circuit, right? So this is up to here. This is the mode 2, right? So now in mode 3 operation, T2 to T3, right? Now look at here. At the end of this mode of operation, if you observe, now this positive is applied to cathode, negative is applied to anode. Now these polarities are opposite to this T2, and these polarities are favor to this T1. Why? Because minus is applied to cathode, positive is applied to anode. So that's why it will become forward bias. But still it is in off state, but still it is in on state. What is the reason is, if you give the triggering impulse to thyristor T1, then only a reverse current will flows like this within a short moment, right? With a short moment, then only your SCR T2 will be turned off. Otherwise, it will be turned. So see here. So from here to here, this point to this point, the voltage across capacitor will remain same. The voltage across T1 is this one, and this current here 0. So, but T2 is in conduction like this. Okay. So to turn off this T2, so even though your polarities are opposite to this one, it is not sufficient. You have to make the current in T2 is 0. That is possible only this case. Only if you give the triggering pulse to thyristor T1, then a reverse current will flow to thyristor T2, and like this within a short moment, right? Then all the charge carriers will be removed in this thyristor T2, and this T1 will be completely turned, right? So that is T2 to T3 in this way. Okay. So see here, because of this opposite polarity, right? And if you give the triggering pulse, and immediately a sharp rise in current will flows like this, right? In this current will flows like this. So then T2 will be turned off. But I am not showing that dynamic characteristic here. But I have already covered in class C commutation and class D commutation. So because of giving triggering pulse to this one, within a short time, a reverse current will flows like this, and your thyristor T2 will off state, right? So now once you give the triggering pulse to thyristor T1, how the current will flows again? this plus Vs inductor, this transformer upper primary winding, and to line. Okay, so now actually initial voltage polarity is this one, right? Now because of the current is flowing again like this, again some of the flux linking will be like here. So therefore what happens, your capacitor will charge to a voltage of plus 2 Vs, right? So these are the initial polarities, and because of the current flowing like this, and also the current is flowing in this direction, right? The current is flowing in this direction, right? So your capacitor voltage polarity will be reached to plus 2 Vs. This is the initial, right? Further the capacitor current will be flowing in this direction, right? So at the end of this mode the polarities will be like this. So we will reach the initial state, that means this state. So because of these polarities you are having plus 2 Vs. Understand? And because of your SCR is in on state, the voltage across the device is 0, right? Now because of this polarity, positive negative, same polarity, your output voltage polarity will also same like this, right? So that's why charge it is reached from negative voltage to positive voltage, right? Why this slow variation will occur means because the capacitor does not allow sudden changes in voltage, so that's why the slow changes. And coming to this IC, see the capacitor will be flowing in this direction. That means your reference direction, right? So reference direction you just see here. See, this is the reference direction. So the current is entering into the positive polarity of this one, right? So because of that, the current is entering in this direction. So again the positive current will flow, right? So, but here only up to this period only, right? Why? Here the capacitor already reached to a full voltage. Once it reaches to full voltage, the capacitor acts as open circuit. That's why the current is 0. But still your T1 is in conduction because there is no relation between this current and this current. This current will be flowing like this. Okay, right? So there is no relation. That's why still your T1 is in conduction. That means this part is nothing but the first mode of operation, right? So in this mode of operation, based upon your capacitor, only it will be turned off, right? So here we are not using any forced computation because of just having a high voltage compared to source voltage, and by giving a triggering pulse to thyristor T1 or T2. For example, if it is in on state, to turn off this one, what happens? We have to give the triggering pulse to this T2. Then only a reverse current will flow. Then only it will be turned off. Right? Already discussed in the previous mode of operation, right? So just one second. The previous mode of operation. See here, if you observe this T2, this positive is applied to cathode, negative is applied to anode. So it has to be turned off. But what happens? What happens? It won't be turned off unless until if you give the triggering pulse to thyristor T1. If you give the triggering pulse to thyristor T1, then a reverse current will flow like this, and immediately it will turn. That will be in dynamic within a short time. It will be happening. So generally, so this is about your series and parallel inverters, right? For the examination point of view, academic examination point of view, the series and parallel inverter is very important. But for the gate examination, competitive examination, generally these two topics are not required, right? So this is the end of the 5th unit. I have already covered all the concepts in the 5th unit. If you want, you please verify all those things. Okay. So if you have any queries still regarding on this one, just go through this topic, and just refer the textbook if you have. PS Vimra is sufficient for this. Thank you.